Rational exponents and radicals are where we see how the two are related. With rational exponents, something like x to the 1/2 power, that has a rational exponent. The radical is where you start to see what kind of looks like a messed up division symbol, has kind of a check mark on the front of it. That's called the radical, where you have square roots and cubed roots and fourth roots. We're going to see the relationship between those two kinds of expressions. So our target is that we will evaluate cube and fourth roots and convert rational exponents to and from radical form. First, let's make sure that we understand the parts of the radical. So when I'm talking about these different parts of it, that you know what part of it is I'm talking about. So if you have this kind of messed up check mark division box thing, that is called the radical symbol. That's kind of like the house. The number that sits right here on the edge of it, that's called the index. So that 3 would communicate that I'm wanting to know the cube root of the radicand, which is 27. The way that I remember this is the radicand is inside of it. The radicand is in, and so you have that in right there, and that's what makes it inside the radical. And the whole thing is called the radical. So like with exponents, you had the power was the whole thing. The radical is the whole expression. The index, the radicand, and the radical symbol are all parts of that radical. So first, let's look at finding roots. How this is spoken is, what is the third root or the cubed root of 27? To find that, you kind of make this little face in that cube. And you say, what can I multiply by itself 3 times and get 27? If you're not really familiar with cubes, like 1 to the 3rd power, 2 to the 3rd power, 4 to the 3rd power, just do kind of some guess and check. 1 to the 3rd power would be 1. If I had 2 to the 3rd power, well, that's going to be 2 times 2 times 2, which would be 4, 8. That's not big enough. So let's try 3. 3 to the 3rd power will be 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. Therefore, the cubed root of 27 is 3. Let's look at another one. So here we're looking at the 5th root of 32. So this cute little fellow, what he's thinking is, what can I multiply by itself 5 times and get 32? So we're trying to find the root of what gives us 32 when you multiply by itself 5 times. So let's start with 2, kind of how we did here. If I have 2 to the 5th power, that would be 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Therefore, the 5th root of 32 is 2. So start small, do some guess and check, and you'll start to become more familiar with those squares and those cubes and whatnot. Here are a couple of charts that are going to be very beneficial for you in converting between radicals and rational exponents. The squares, you probably know those up to 144 at least, but it will be very beneficial of you to commit to memory 13 squared is 169, and 14 squared is 196, and 15 squared is 225. That way you can recognize those. Just like knowing your multiplication facts have really helped you along the way, now knowing your squares and your cubes will also help you. It just makes life easier. It's completely fine to get an index card and write this list on an index card. Keep that in your textbook, have it in your notes. Just have it somewhere that you can easily reference. So for the cubes, there those are, and you can see that they get bigger a lot quicker. That is called exponential growth. So let's convert a little bit. Here we have the radical, and we're wanting to turn it into a rational exponent. So what that means is I'm taking it from this form here, and I'm moving it to this form over here. Now let's pause for a second, and let's talk about these conversions over here. So notice the green X, that is your base. Your base moves to the radical. And then the fraction here, A over B, the A goes inside the house, the B turns into the exponent. I had a student last year that the way that she remembered it is right now the B is being shielded from the rain, But he says, oh, you know what, A, I'm going to let you have a turn to be shielded from the rain. So B says, I'll stand out here in the rain, and A, you can be shielded under the radical. So they take turns and they swap back and forth. That was the way that she remembered it. I thought that was pretty clever. Now let's connect this to something you are comfortable with. You know, for instance, that 9 to the 1/2 power is 3, right? Because 3 times 3, a base of 3 with an exponent of 2 gives you 9. Well, that's also the same thing as the square root of 9. If there is no index written right here, it is understood that it is a square root, or you could have a 2 right there. So see how that fits in to what is being shown in this diagram. The 1 is put inside the house. So that's the same thing as 9 to the 1st power. We can just write that as 9. The 2 is set here on the ledge. It was being shielded before from the rain. Now it's going to sit outside and let the 1 have a turn underneath. And the 9 stays 9, but it moves from being a base to being part of the radicand. And notice this only works when B is not equal to 0, meaning that you're not going to have an index of 0, because that is, like you can't have a rational number with a denominator of 0. So now let's practice on converting these. 2 is being shielded from the rain now, so he's going to let the 3 have a turn of being shielded. So that's going to change to be x to 2 over 3. You can see how that matches up with the diagram. Think of the 2 as like the A. It was underneath and now it's above. The 3 is like the B term. It was out and now it's under, and the x stayed x. Now here with the 4th root of 256, a to the 8th power. So we could take each of those there, 256, a to the 8th. If you'll notice, the 8 does not apply to 256. It only applies to the A. If it had applied to 256, there would have been parentheses right here. But since there are not, it's only being applied to the A. So the 4 is going to be going underneath here. And since there is no exponent listed, then it's assumed that it is a 1. So we're wanting to know the 4th root of those. Now let's take this a step further. Let's connect it to what we saw in our previous lessons where you have a product to a power. That means that I can take 256 and I can raise it to the 1/4 power. And then I have a to the 8th raised to the 1/4 power. Okay. When I'm trying to find 256's 4th root, meaning what can I multiply by itself 4 times and get 256? If I start with 2, for instance, I know that 2 to the 4th is equal to 16. Can I bust 16 out of 256? So 256 divided by, whoop, that's add, divide by 16. Oh, that is 16. So what that tells me is that 256, like if you were going to make like a factor tree out of this, could break down to 16 times 16. And my 16s could break down into 4s. Therefore, 256 is equal to 4 to the 4th power. What that means for us is that 256 to the 1/4 power is 4. So that takes care of that part there. It was a perfect 4th root. Now, a to the 8th to the 1/4 power, I'm going to multiply 8 times 1/4. So 8 over 1 times 1 over 4 ends up being 8 over 4, which would be 2. So that simplifies down to a squared. Now let's go back and think about this right here. Let's kind of erase some of this. The 4th root of 256 was 4, and then the 4th root of 8 was 2. See how you're really dividing 8 by 2? Taking the root of a power is like what we did on multiplying a power to a power. Taking the root of it is where you're going to be dividing those exponents. Now let's go the other direction. We are given it with a rational exponent and we're wanting to turn it into the radical form. So 54y will be the complete radicand. 54y. And since it's in parentheses, that whole thing is being raised to, let's think of where the a is, that's the 2. That is going to be squared. And then that is to the third root right there. Now we need to go ahead and apply this squared right here to each term inside those parentheses. So the third root of 54 squared, let's get that calculator back out. 54 squared, so 54 times 54 is 2,916. And then y squared. Okay, so I want to look for some cube roots that could be factors of 2,916. So we're going to keep 2,916 in our brain here. And I'm going to take this cube root chart. I'm going to bring it over here to this slide. Now I had suggested to you that maybe you would have it on an index card or something, so this is where this would be beneficial that you're bringing it over. Okay. I'm looking at these cube roots to see if any of these are factors of it. Let's divide that by 8 to see if that is a factor of it. It does not come out even, so that doesn't work. So let's try again. 2,916, let's divide that by 27. Ooh, that one does work. So what that tells me is that 2,916 can be broken down to 27 and 108. How this helps us is the third root of 27 is 3. So that pushes 3 to the outside of the radicand, and I'm left with 108 inside y squared. Actually, then I have that 3 right there. Okay, third root. So 3 is like a coefficient of it now because the cube root of 27 is 3. I have extracted that from the radicand. Now let's continue with 108. Can 108 be broken down by 27? Well, yeah, it can. Divide it by 27 and you get 4. So I kind of had to make my factor tree go sideways, 27 and 4. So I can pull out another 3, so I have 3 times 3, third root of 4y squared. 3 times 3 is 9, so my finished product is 9 times the cube root of 4y squared. If you're a little bit panicky looking at that and you're saying, well, I have no idea how she did that, this is the kind of stuff that we'll be practicing in class together. And it's like a continual puzzle that you're trying to figure out. Now to do this bottom one, I'm going to make some more room. I'm actually going to take this example right here and let's bring it to a whole nother slide so that we have plenty of room. Okay. 5x to the 1/3 power. So first let's put that into radical form. This is going to be the third root. The 3 was underneath now, so it's going to swap and come over here. And the 1 is only applied to the x, and it's to the first power, so I don't really have an exponent underneath there. And 5 and actually, the 5 is not part of the third root. Only the x is part of the third root. So the 5 comes out in front. This right here is what changed to the radical, not the 5. If that had been 5x in parentheses to the 1/3 power, then the 5 would have been in the radicand. But since it's not, it stays like that. 5 times the third root of x. And that would be your simplified version of that in radical form.